Jesse Reiser's lecture on the first night of Candidacy Week for the Design Research Lab at the AA. We're very honored to have Jesse here with us for a few days. For the Candidacy Week juries, which are tomorrow and the next day from 10 until 6, and which are entirely open. We hope the whole school and outside the AA are very welcome to join us. And Jesse is one of many jurors. Also tonight we have Caroline Boss and several others who will be joining us over 2 days. Jesse's also here for the Landscape and Urbanism program for a short workshop. It gives me great pleasure to introduce Jesse, whose work I've followed for years. And I think from the last time he's been at the AA for the very same event, 2-day juries for the Design Research Lab in '98. I think the career of the practice of Reiser Umemoto has sort of rocketed, not out of control, certainly with great clarity, precision, and sort of ongoing project from project to project. Just some brief history to introduce Jesse to you, if you don't know. Some of the background educationally. Studied architecture at the Cooper Union, graduating in 1981. Then completed a Master's of Architecture at Cranbrook Academy of Art in 1984. Following set up Reiser Umemoto Architecture with Nanako Umemoto in 1984, the very same year. Has published and exhibited extensively and taught all over the place, including the AA, currently teaching at Princeton University. Has also taught at Columbia University for many years, Yale, Princeton, Berlage Institute, Kyoto University, Stadtschule in Frankfurt, and perhaps elsewhere, I'm not sure. We'll see several projects tonight, I'm sure. In the recent years, some of the outstanding competition entries that we've witnessed are the IFCCA Prize in New York, commissioned by the Canadian Centre for Architecture for a project for the Lower West Side of New York, Graz Concert Hall, Kansai Library, Yokohama, and several others. The list would go on. And the practice has also an extensive portfolio of built work. We're very pleased to welcome Jesse Reiser to lecture tonight and to the Candidacy Week for the Design Research Lab. Please join me in welcoming Jesse Reiser.
Thank you, Tom, for the introduction. It's always great to come back to the AA. I always feel it's a kind of wonderful, warm sort of club feeling that one misses in schools in the States. So it's always great to have this kind of interaction and to see the work that's in progress, because it's somehow always been, to me, even before I got to know this institution, a very kind of close place for all of the people who taught me. So it's great to come over the years and to be connected to all of you and to the work as it develops. I'm going to show 2 projects that we've just completed in competition. One was the Graz Music Theater that, of course, Caroline knows very well, and that Van Berkel and Boos ultimately won. But it's important to show it, not simply to show just another project, but because it really leads in to a lot of the work and the ideas that connect to the other project I'll be showing, which is the IFCCA competition entry for the west side of Manhattan. So before I do that, I wanted to take somewhat of a risk and to present a paper that's still really being formulated, but it's for a kind of belated issue of a magazine that Jeff Kipnis and Sanford Quinter are putting together called Rumble. And so I hope you will forgive the tone, which is polemic and also enthusiastic, because it's really more directed at colleagues and friends than, I guess, trying to put forward to the greater architecture world some sober thoughts. So I guess I'll just begin. Lights. Are the lights going out? No. Okay. And then this is the forward button. Okay. It's entitled The New Fineness, and really it comes about first from the direction of the work that we've been developing. I'd say that I'm not, by any means an architectural theorist, so the direction and kind of development of the thoughts here really arise from the process of designing more than from some body of systematic theory. But it was really intended to address a kind of frustration both in our own work and also in the work of our colleagues, a kind of limit that seems to be reached in terms of the development of what one could say kind of crudely as gross form. That there seems to be a kind of wall that everyone hits, beyond which there seems to be very little chance of development. And one sort of way around this, one thought or set of thoughts that I'm trying to put forward tonight addresses this kind of problem. And we typically see it in the kind of proliferation of single surface projects, topological projects that are only interested in kind of developing proliferations of a single surface ad infinitum. So not to say that that's wrong, but it also represents a certain kind of scalar limit that seems very difficult to break through. So that's the sort of direction. There are other kind of polemics here as well, but let me just kind of dive in. The time has come, once and for all, for us to throw off the last limiting vestiges of anthropocentrism in architecture. We stand at the brink of a radically expanded field whose horizons are restricted only by our material imaginations. The sublime has arrived not in the lineaments of some latter-day metaphysics, but instead as a material fact. The past 2,000 years have been dominated by myths of architecture's dream of humanizing itself. There is no doubt that architecture has in the past and will continue to have such aspirations projected on it. But just like the sea, or say money, architecture operates in the elemental. It is neither inherently human nor inhuman, but rather exhibits a profound indifference. Herein lies both its limitation and its potential openness. Just as the sea is given a countenance or a mood, or money has the ability to act as the medium of universal wish fulfillment, the true nature of their respective proliferations lie not in their personifications, but in their behaviors. To turn it around, the actual personifications are derived impersonally from the dynamics in material systems themselves. The much vaunted notion of the death of the author, and by extension the subject, might be seen here in a new light. That really neither the author nor the subject ever really existed as coherent entities in the first place, or at best, they existed only as temporal historical inventions whose time has passed. Individuations in thought and in the world exist because both emerge from a dynamic which inherently produces such singularities. These dynamics, however, move along specific pathways, producing expression in various material practices according to the internal logics of those practices. This returns us to the question of architecture as a discipline. The questions that beg to be answered, and that's to guard against the kind of erroneous confabulations that the preceding thoughts tend to produce, is this: how is architecture both similar and different to other material systems, and what is the specific nature of the connection or links among material systems? Before striking out at the extended implications of architectures of this question, we must first put forward a logic of relation within the discipline itself, a field that has recently been asked of late to define itself and seek sustenance from a plethora of external disciplines, each claiming to represent a new way of invigorating architecture. In the 1930s, the French structural engineer Robert Lericollet already outlined a chain of material relations which, by virtue of engineering's inherent overlap with architecture, serves as a partial model. Lericollet produces a continuum that brings together matter, materials, constructional systems, structural configurations, space, and place. And he goes on, this is a quote, all materials receive their isotropy from the directionality of their process of production, both natural and human. All equipment and processes have preferred directions of use, which gives directionality to their products. This applies to basic materials, fabricated subsystems, and complete buildings. Thus, the construction system too receives its isotropies in space and in time from the mode of production, i.e. its nature. And further, structural intuition is synchronous foreknowledge of mind and foresight, I, of a form that derives its configuration from the directional geometry of dilations and contractions, extensions and compressions, of natural forces and human activities in space. Lericollet recognized new proliferations in structural behavior because he rigorously avoided the tendency to either idealize or purify the structural systems he was developing. Further, he avoided the tendency to project values on the outcomes of his structural experiments. Structural failure was not seen as a negative result. He felt free to pursue changes in states of matter to guide the development of new structural systems. The familiar transitions from elastic to plastic to failure in materials were allowed to develop in a structural assembly up to and beyond the point of failure. This procedure in and of itself is neither novel nor surprising, but what is interesting is Lericollet was not simply seeking the limits of a particular assembly, but instead was actively looking for new configurations in the structure generated on the way to failure. Ultimately, he discovered these new deformations to be more load-resistant than assemblies in equilibrium. Like many innovations in the history of technology, these new insights would lie fallow without the conjunction of other models of thought and technique. The continuum of matter to space that Lericollet outlines, in effect, a notion of the diagram, is broken by historical circumstances, which is an engineer working under the constraints of architects controlled by modernism. What this means at the systemic level is that the geometry of dilations and contractions, extensions and compressions is relegated to the simple assembly, while the cascading of effects to larger scales of organization remains ideologically unthinkable. It is ironic that Lericollet was an engineer for Louis Kahn, an architect universally admired for his humanistic approach. For Lericollet already realized the chasm that was beginning to open between material logics and humanistic projections. Humans are anthropocentric, he writes. Their bodies experience three orthogonal axes of up and down, front and back, left and right. However, neither space nor natural forms answer to these human axes. They are not anthropomorphic. Lericollet brought a non-anthropomorphic attitude of the mind before the unknown. He believed that the experience or contact with things or phenomena enable the mind to escape the anthropomorphic, where your eyes can help your mind. . ' Le Ricolet's model of continuity is populated by the obvious disciplinary categories familiar to the engineer: materials, forces, and space. These, however, are not solely the property of the engineer, nor, for that matter, of the architect, but are common to all material systems and even implicated with material thought itself. Thus, the dynamics of any material system will find common currency with others. In this sense, the dynamical relationships are unoriginal. Thus, while they appear to be derived from systems apparently outside of architecture, and so would seem to be permanently representative of these systems, they in fact are general structures which reside in these special cases. Further, while such relations are necessarily reductive of the phenomena they map, it is this quality which allows for their effectiveness in architecture. It follows then that such conceptions allow for architecture's participation in a kind of universality, a notion that Manuel de Landa refers to as mechanism independence, and that is that one and the same mathematical mechanism can account for a multiplicity of events that would otherwise seem to be wholly unrelated. Therefore, it would be as valid to say that architecture might involve itself in kindred forms of order, as the weather or the onset of turbulence in a liquid, not because it takes those phenomena as a referent, but precisely because it reduces or excludes the phenomenal dimension and instead maps only its dynamics as vectors, fields, or fronts. By virtue of a dynamical diagram's reductive treatment of its nominal content, it can be shifted. It then becomes possible to engage in an architectural systematicity, which in turn allows for its rematerialization in the stuff of architecture with all of its attendant phenomena. By its very applicability, the dynamics are inherently architectural, and from this point of view were never anything else, neither metaphor nor symbol, but a literal expression of organization in matter. Inasmuch as the work of architects and engineers ultimately overlaps the same material construct, their respective procedures already find expression in a common material field. While architecture necessarily exceeds the reduced parameters of engineering, the interest in structural logic stems from the fact that they provide the most direct and literal index of forces in matter, even in typological models, and would serve as the basis for any significant departure. This direction of work has no aspirations towards innovative engineering per se, but rather for the pursuit of architectural effects. Increasingly modernist paradigms, especially ones that would seek to purify or reduce practices to a certain limited set of criteria. For example, when an engineer strives to find the most minimal structural solution, i.e. something like the purest tensile structure, by all evidence have reached their limit, and in all likelihood will be unable to produce new possibilities within the same criteria. A materially based methodology for generating architecture would naturally involve the interaction of matter and forces in reference to an extended field whose qualitative and quantitative behaviors are crucial. The material behaviors which interest us and which abstractly determine the outcomes may be expressed in the interaction among, as I mentioned before, vectors, fields, and fronts. In short, vectors have a force and directionality that shape, organize, and produce variation in a field, and that the fronts are singular features produced by the dynamics of the field. If we allow a dynamic to flow through Le Ricolet's model of continuity of material constructs, then a relationship among these elements becomes evident. Forces passing beyond the scale of a single component towards larger scales of organization in building, such as that of a fabricated subsystem, will, if properly configured, begin to display field behaviors. In order to go beyond simple deformation, this field must be non-isotropic, which is to say that both the materiality and the geometry that define pathways for this proliferation is not uniform, but variable and differential. This might be regarded as the moment organizationally where the conceptual threshold or limit of modernism is crossed. In the case of both Le Recollet and Buckminster Fuller, their conceptions of the extended structural field were both trenchantly modernist, equally isotropic and isomorphic. While Le Recollet experimented with the deformation of a component, he could not extend these principles beyond that scale. Geometry and the conception of matter and space developed in an equal field based upon the repetition of equal units, idealizing both matter and space. But what are the means to move beyond this threshold? Just as the nature of space itself should not be understood as uniform and empty, but rather as coextensive with the flows of matter, so too geometry as an instrument should be linked to a materiality. Recent developments in form-finding computer programs enable us to assign material properties and behaviors to a geometry. And this can also be achieved in actual physical modeling, as for example, in variations of the well-known catenary models of Gaudi and others. The coupling of geometry with material properties in its simplest form may be understood as operating within the geometry of a single spline or materially within a single catenary. These, however, are both quantitatively and qualitatively too reduced to display any complex behavior. In order to do so, they necessarily have to be linked within a system of repetition, yielding a bottom-up organization. The relationship between their behaviors as a linked system becomes evident in the generation of actual singularities when certain thresholds of quantity, geometry, and forces are reached. Let it be understood that this is not a matter of producing a differentiated structural field for its own sake, but rather as the consequence of and in relation to the real differences that an engagement with form, program, and organization would impart. These orders would have to be brought in from the outside and further have the ability to lock on to the bottom-up organization. The new configuration would then operate from the top down and would extend to the profusion of possible organizations of which matter is capable. Again, there would be two possible modalities within which to generate fields of repetition with this top-down approach. First would be about managing geometry and force directly within the catenary field, as mentioned earlier, the material computational model. And the second approach, which has a more analytical dimension, establishes the geometry of the force field within the already given model. The top-down and bottom-up modalities of conceiving organization are flexible tools to be used reciprocally and through as many scales as would define the project in question. Either model in and of themselves are not adequate, but if used together, have the capacity to form new organizations through feedback. While this approach involves intensive integration and synthesis, this is not the aim in and of itself. The argument here is that the cooperation of finer relations yields overall architectural effects that are greater than the sum of its parts. Organizationally, the cascade through local relations has global effects. These issues will be further elaborated through a discussion of a recent project for a water garden for Jeff Kipnis. Just as the upward thrust of a mountain range breaks up the orderly flow of winds around the Earth's surface, creating local eddies which in turn affect temperature and rainfall, so the variegated peaks and valleys of the water garden exert a spectrum of turbulent effects on the flow space of the garden. And like the relative fixity of the mountain range, whose movement could only be mapped in geologic time, versus the rapidity of the weather, the time, materials, and forces involved in the strata of the garden embody radically different times of formation versus times of effect. Indeed, while the origins of the diagrams that determine the three strata of the garden could not be more disparate, their exchanges are not. The meaning of the relationship among them arises not in their origins, but in the way the diagrams communicate through their material incarnations. While history is not communicated, force is. The magnitude and direction of a force, its vectorial resultant, finds expression not simply in itself, but non-linearly in the adjoining media. These exchanges, while mutual, are not equal. The dominant media, in this case the fixed geometry of the slab, exerts proportionally greater influence than the relatively weak forces of the flow space. This is not a simple dominance, however. Lateral efflorescences, mineral and vegetal, engender moving tracks that crisscross the flow space, dissipating the determinations of the slab. In addition, the fine-scaled effects of surface tension and meniscus are amplified by the ogive geometry of the grooves. Every change in water level results in a new and changing constellation of puddles and walking surfaces. Such effects are accelerated as the water rises because the geometry of the ogive tends increasingly towards the horizontal with every increase in vertical dimension. For a variety of reasons, architecture and engineering have inherited the mean as a virtue. In this work, we are looking instead at conditions that are both too fast and too slow, too small or too large to be described by the average or the mean. Indeed, it seems that the extremes have a way of working together to produce new possibilities. We are witnessing a tendency towards a new fineness. An example of this comes from the allied field of aeronautics. Increasingly, engineers have realized that diminishing returns are to be expected from the simple manipulation of gross form. Innovations in metallurgy, in modeling aerodynamic behavior, and in laser fabrication have opened up a whole horizon of possibilities in aeronautical design. Here, the very large is synthesized with the very small, the very slow with the very fast. The ability to fabricate the metal skins of airfoils with literally millions of laser-cut pores have radically extended the low-speed performance of aircraft to such a degree that their actions appear completely counterintuitive and unnatural. The capacity to radically extend maneuverability in that strange, unstable region at the edge of stall suggests an analogous possibility in architecture, allowing for the incorporation of extreme yet codependent regimes of scale and organization. Confronting such a model would, among other things, serve to address the apparent paradox of the global and the local occupying the same space. As history demonstrates, the most humanistic architectural projects produce the most inhuman effects. Architecture must become renatured so that it is no longer operating as a denatured lineament for some impoverished idea of man's work in nature, but rather as a fully artificial engagement in harnessing the unfolding natural processes. We must, in a generous spirit of forgetting, turn our interests towards a synchronization of scales, forces, and matter, recognizing a true vitality in their rhythmic unfoldings. Okay. This is the first project I'll be showing. Again, it's the proposal for a competition 2 years ago for a music theater and performance space for the city of Graz. It's actually attached to a university, and this building has a kind of dual function of being both a public performance space, but also an educational facility for both music, theater, and orchestral performance. So there's a kind of daytime use, which is related mainly to the college, and then more public nighttime use. And here is the site plan to the right, gives an indication of the location of the building and the necessity. Part of the requirement of the brief was to create a kind of accessibility for the main flows into the space of the theater through the adjoining courtyard of the buildings you see to the left. In working out this project and really in presenting it here tonight, I want to sort of show what happens both in terms of the process of designing building in competition, but also to give you an idea of some of the thoughts that were sort of cooking around this project. So this is how we presented it at the end of the second stage. The notion here was that it would be a kind of a building made of two types of constructional systems, and those two systems of construction actually programmatically encompass the two basic sort of uses of the building. So on one hand, there was a kind of modified plinth element which contained all of the sort of functions. It's a steel frame with glass infill. It contained all the functions of the music college and the rehearsal spaces and production spaces and so forth. That married to a reinforced concrete structure which housed the performance space, and sort of connecting that, cantilevering off of that is a reinforced concrete shell, a kind of conoid roof that cantilevered over the what would be the foyer space for uses in the evening, and then the more kind of public daily spaces for canteen and so forth during the day, during the kind of school use. So that then was, the idea was that those two building types would be joined by this structural skin and curtain wall that would basically take up the difference in the geometries of the two building types. It would kind of mediate between the two, and most public flow up the kind of main staircases and so forth would happen in that in-between space between the two buildings. So here are the kind of elevational views, and you can get a very clear picture of the kind of separation between the two elements. And in section again, the main performance space. Oh, I have a laser pointer here. Main performance space, the cantilevering conoid roof, again the kind of public space of foyer and canteen, and then two rehearsal spaces underneath. Here again a plan of the ground floor of the space, the music rehearsal theater, orchestral rehearsal theater happening at the main floor. This is also adjoining a park site, so the that facade can be opened up, and there would be the possibility of having that kind of performance on good days flow out into the park site as well. And then here, in both physical model form and also in the renderings, a very clear picture of the kind of separation of the two and how they essentially kind of the plinth element locks together then with the reinforced concrete element of the theater space. And then here, the performance space that would house at most 500 in different configurations. Proscenium stage, a center stage, and then this kind of surround stage. And then a view into that public space and foyer. So the kind of manipulations we were making, both of the kind of the flow space moving up the kind of grand staircases that flank this plan. It's quite symmetrical in character and has really modified locally with the asymmetries of program, but basically a symmetrical planning scheme. And then the two elevations here, the face that kind of faces out towards that courtyard would be kind of place for electronic signage and so forth, sort of blank face of that. And then this is the rear view looking towards the conoid roof and the open foyer elements, and then again the kind of functional disposition of elements below for rehearsal on this side, and then changing rooms and so forth behind that facade on that side. Okay, so that is, in a sense, I guess the more normative and the kind of final presentation. But then there was another life to the project, which happened and occurred up to the midway point when we really found out the budget. There was a more sort of experimental direction, which finally came to kind of greater fruition in the IFCCA competition. And so prior to really finding out both the budget and the kind of strict requirements of producing an absolutely regular box, there was another sort of dream and another sort of proposal kind of lurking inside that box. And that was the development of a space frame system that essentially and kind of notionally would be a very fluid kind of structural model that would be kind of notionally taking this fabric of structure and pushing it into a regular kind of boundary, and that there would be a kind of regularity of the external boundary and a regularity within the internal boundary of the performance space, and then you would be essentially developing the kind of the rich mixture of structure and flow space in that in-between structural sponge. So this were the initial models for that. This was an alias model. We essentially started out with a bias towards the geometry and the kind of description of the structure through this alias modeling, and then brought it to our structural engineer, who said, okay, that's fine, you know, you're doing all of this wonderful work in the geometry, but it ain't going to work structurally until you really find another kind of more material definition for developing this. So he suggested that we could base this procedure on the model and the kind of paradigm of Gaudi's. You know, this is the famous catenary model of Gaudi's Sagrada Familia church. The problem here was that Gaudi's sort of problem situation, if you want to call it that, was fairly simple, because he was working entirely with gravity forces on the catenaries, and they could be quite pure in configuration. It was about linking them. We, on the other hand, because we were dealing with literally a multi-dimensional set of forces, ones which weren't just responding to gravity, would have to start with a more or less similar model to Gaudi's, but then start literally pulling and tugging on that model in order to produce the kind of vaulting and the structural field that we were interested in. So there was a kind of, not even an analogy, but it's very, very similar to what you would find in other kinds of material systems where you have a number of different forces operating at the same time. This is what they call the kind of tongues of wine. And what it is that you have a kind of battle of forces occurring between evaporation and surface tension and gravity. And so you get these strange tendrils appearing inside a glass of wine because of those various kinds of physical and chemical reactions happening in that surface. A similar kind of condition occurs in the catenary field, where you're dealing with totally different and kind of multi-dimensional forces happening in the structured field, and you get not only the kind of interesting mixture, but if one begins to analyze the regions of difference in that field, then it becomes even more compelling as a procedure, as something that would suggest an architectural kind of involvement. What happens is there are certain zones of, one could say, purity in the field, where it's essentially similar to the Gaudí condition. There are other places, though, where the forces are really much more pronounced. There's a kind of confluence which would cause a deviation in the field, a kind of curvature in two directions. What happens there is that it's the kind of sin of modernism. You get bending occurring in that zone of the structure, which means it can no longer act in a pure state, but it also then, if you're designing it, means that that's a kind of hard point where there would be much more resistance. So we were looking at these opportunities, and just as a kind of notional idea, for where heavier program would actually start to lock on to those regions, because you get this kind of shift from a very light structure to a much more resistant zone of structure. So it was very interesting that you get a kind of, it's not something that one can predict, but it would be something that one could manage in developing a project. It was a very interesting set of outcomes, and it really was much more the thought here, because we never were able to progress with it, but it was something we then really tried to pursue in the IFCCA competition structure. So here is the catenary model that we made, literally gluing the alias printout to a door and then attaching these chains to that on hooks, and then creating essentially enough of a field that it would display a behavior. There would actually be this strange moment when the mass of catenaries would, as you worked on them, suddenly snap into place, and it behaved in a way that was very different from, you know, when you added only a few catenaries to the field. So it was a strange moment of quantity and force, and then you suddenly saw the thing snapping into a configuration that was very much like the alias, you know, drawing. And the differences between it and the alias drawing were also actually productive ones. Well, that's that. I didn't realize I ended so quickly on it. But anyway, this is the second and final project, and then really there is a kind of continuity, even though it's very different in scale and in intention, to those experiments in the earlier project. This, as many of you probably know, was a competition that was assembled and sponsored by the Canadian Centre for Architecture, and after the initial sort of submission of interest, the selected participants were Cedric Price, Peter Eisenman, Van Berkel and Vos, Tom Main, and us. And really, it was a very kind of compelling and interesting site, maybe especially for us, since it was the last unbuilt and undeveloped area in Midtown, to the west of Midtown, Manhattan. And it is a very unique site in that it's dominated by this enormous rail cut. And so the possibility really here is to create a project of a scale and of a kind of systemic nature that would be very different in possibility from other regions of the Manhattan grid. That there was this kind of unique opportunity of both dealing with the pattern of the grid, but at the same time being able to transcend the kind of breakup and scale of the normative fabric and deal with a kind of super-scaled possibility. And practically everyone, I think, recognized that as a possibility and developed it, you know, in their own ways. So basically the idea here was that you would have also the confluence of both visible and invisible systems that cross that site, global systems, and how you would manage to kind of deal with these global systems of transportation and culture and exchange in a localized zone, and what the possibilities were with that. So here again the kind of context of what were the Pennsylvania rail yards, and finally we went to as the railroad developed and was bought out, went to other entities, but still an active rail yard and conduit. We basically split the project into three main layers. There would be the lowest, most level, the kind of functioning of the rail yards, the connection to Penn Station, and its kind of conduit both to along the Northeast Corridor. The surface condition of the project, which for the most part we saw as being related to the functionality of the grid, and that we would still allow, with the exception of closing off 2 streets, the grid to work at the surface level. So you had a kind of local condition sandwiched by a relatively local in terms of neighborhood global in terms of neighborhood scale of this uppermost level, which we put forward as both a kind of natural and artificial parkscape. So it was a kind of sandwiching of global, local, global. And here again, the kind of initial sketches of that conception of the grid. Below that, the rail yards, and then the kind of elements of flow that we would try to capture. There was a kind of ethic of making all of the programmatic proposals contiguous and connective with every other one. So there was a kind of weaving of programmatic layers as well. So here again, the main sorts of infrastructural flows through the site, the New Jersey Transit and Amtrak. What we took very seriously is the extension of the number 7 line, which will happen. There is also a call by the Regional Planning Association for a light rail loop that could conceivably move through the site. So we saw this kind of nexus of conditions, not just as flows through the site, but as places where programmatically one could actually associate very specific types of program. Because with each type of flow, there would also be a population associated with that flow. Commuters in one hand, kind of relatively local residents using the light rail system, or those coming from other parts of the city, for example. And each one could be then tapped into and associated with a kind of programmatic configuration. There was also, in terms of our reading of the situation, the necessity of taking seriously the extension of the Javits Center, of doubling its square footage and of extending it to the south of its present state, of kind of essentially doubling that floor plate. And with that, in consultation, and I should say this also, this was not just a project done solely by our firm, but that we collaborated with Israel Sinek, who is a major kind of structural engineer and builder in the city, and then also Buckhurst Fish and Jacquemart, who are planners and transportation planners, and also related to the local community board. They were liaisons for the development of the Hudson River Park, which crosses on the west side of this site. So in discussions with them, and also with another consultant in terms of who basically talked about the monetary possibilities and conditions of the site, the financing and so forth, there was a necessity, if one were to extend the Javits Center, that you would also have to build hotels, like 3 major hotels, which are those towers here, of 3,000 rooms, that would essentially, allow this to become not just a kind of satellite and a place where one, there's also a kind of, this is considered to be like a 3rd or 4th rate convention center presently. In order to really make it something viable, there would have to be a kind of conjunction of those functions. And hotels shouldn't be remote, they should be right there, that this would be a kind of center unto itself when finally finished. So these are the various types of access, the commuter access along the corridor, also from ferries along the water's edge, again, the kind of synergy among programs, the Javits Center and these hotel towers. Also the necessity of making this viable in terms of rental of that kind of development. There was a determination that we needed to create 5,500,000 square feet of leasable office space. So that was developed under these wings here, which are under the park and also in 6 towers that are in closer proximity to the station. So there was a kind of battle in the development internally in the office too, between the sorts of necessities, pragmatic necessities of developing in the city, and then the whole sort of the issue of public space, and also, of course, our own sort of organizational and formal agendas. And so that was the sort of situation in terms of the forming of the project and the discussion of the project. Here, the idea that there, of course, are great parks in the city. There are great open public spaces, but there is a kind of shortage of enclosed vast public space. And our idea there would be a kind of a really enormous event space that would be left relatively open in terms of its possible functionality. It could also at times even deal with overflow from the Javits, but it would really be in its central zone a fully public space. But because it would need to be financed, and it would sort of need other kinds of sustenance than just public funding, there was an interest both formally and organizationally in creating zones that would bleed and connect the shopping elements of the project. There's a kind of linear shopping mall that connects into the station and connects to this Javits Center, of creating the kind of overlap zones as well, where there would be kind of themed shopping and events. These are new forms of essentially commerce. So here in the diagram, the extended Javits, the floor plate, these 2 yellow arms weaving above and under towards the station are kind of essentially the shopping arms, and then this upper level, the linear park. And here at the kind of water's edge, the idea was that there already in reality will be the extension of the Hudson River Park. And what we were interested in doing was taking that organization and basically pulling it in, actually making the park extend all the way to 8th Avenue. So at the uppermost level, the diagram would be of a fully public space. And then under the sandwich, you would have this mixture of both public spaces in the center and then more privatized and commercial spaces around it. So that there was a kind of formal and organizational interest in producing these mixtures, which we felt would be actually more robust than separating them out. So here again, the mall complex. The idea, too, that the extended Javits and the hotels wouldn't be enough either, that there would be the necessity of creating a kind of programmatic mixture. And so we came up with the idea of 5 major cultural programs, 4 theaters, and a kind of large endless museum that would act both as programmatic zones and destinations, but would also serve as conduits sectionally through the project. So we were looking at the programs for and kind of mining them for that kind of interest. Here's a view of the uppermost level, these sort of linear park bands that extend from the river to 8th Avenue. And here's the kind of diagram of that whole park system, the green space along the edge. All of this, it looks like roadways, but it's actually the strands of green space. And here in the rendering, a closer picture of what the nature of that kind of space would be on the sides. A view from the Penn Station. Below here, the Farley Building and Post Office, which will now be converted into the Penn Station. The 6 flanking office towers, and then the 3 hotels. And here you can see a kind of overview of the whole project, a kind of notion that there would be an artificial scape in the center of the space frame and the kind of programmatic bleeds of those 5 programs through the space frame, and that direct sort of linkage and to the green space of the other part of the park. So there was, just as a kind of elaboration of that, there were models, there were prior models that talk about this. One was Buckminster Fuller's 1950s project for enclosing Midtown Manhattan in a geodesic dome. And so we were very interested in this idea of a vast artificial kind of enclosed environment. But there was also this possibility now of looking at repetitive structural systems that would be capable of these long spans in these environments in a basically different way, that one could see this not as just a long span structure, a big roof, but because one is able now to create repetition and variation within the repetition, that would be a whole range of possible kind of programmatic inclusions, let us say, within that system. So these were sketches we were making initially about different types of inclusions, which ultimately would relate to programmatic difference in the space frame, and also even a quite literal, I should say, interest in flow patterns and in turbulence, that it wouldn't be like a metaphor here, but that we would actually be dealing with the flow of structural lines and literal turbulence in a structured field, and not any kind of metaphor of the thing, but getting as close as we could to producing it. So here again, a kind of notional idea of the kind of regular structured field, and then the kind of external forces that would form that field, and then internal variation as well that would sort of produce local zones in it. So an idea that there would be these long span zones here over essentially the mall area and the tracks, and then where it was studied with the 5 programs, there would be a much more localized and intimate kind of artificial scape produced. So this is one of the impressions of the event space, looking internally if it were developed as a kind of golf course zone under this kind of long span roof. And then this is a model of the event space as well. We're also, of course, looking at precedents of people like Olmsted in terms of the programming of those spaces, that it would be unwise to really give an absolute programmatic definition to the space, but that we would produce a variety of scales of spaces and very definite adjacencies to more definite programs. So like the park space of Central Park, Olmsted would not have known about rock concerts, but he produced spaces that would easily accommodate that kind of programming and have those possibilities, even though they were unforeseen. So that there was a really question of not making decisions too, of defining it highly, but not of putting a label on the space. Here also another image of a Woodstock-sized concert. We estimated you could get 90,000 people into the space as well for events of that sort. And then here a kind of model, computer model of the various zones of the space. It was also porous, that one could actually move through a number of levels in this space. It wasn't simply a single surface, but that it kind of combs together a whole series of surfaces and zones. And here again, a notion of the different types of flow in the project. And again, we were looking at some fairly conventional patterns of theaters, but then trying to tap into the flow space with them. So anything like a foyer would become part of movement space as well, and then what would necessarily have to be closed would become a kind of object in the flow. Here, something like the Endless Museum was almost pure flow space. And this came actually from a modification of Corbusier's plan for an endless museum and turning it into a spiral. So that's actually Corbusier's plan, not ours. I shouldn't take credit for that. But it was, when doing a planning project, you kind of take things very quickly. It's not a question of developing all the details, but of getting to a certain specificity. rapidly. This is a kind of cross-section through the whole project. And again, I don't want to get into all the details of it, but the notion that there would be a real close proximity of all of these programmatic elements, and there was a kind of conformal notion of the space frame really interacting with the strands of programming below and making continuity with them. Again, the path system that actually moves through the roof, that it's a habitable sandwich, and a rendering of that space frame structure, and then the kind of flanking park. The zone of what we were interested in kind of creating programmatic bleed out from the specific program here, the Spiralwood Museum, into zones on top of the space frame and in the space frame. And then the physical model that we created, a component of it. And here, the sort of section through all the components and levels of the project. We had a number of discussions with various people with totally different ideas about how this project could potentially be staged. And the one that actually came to be the most compelling to us actually happened after the competition. We spoke to the engineers for Peter Eisenman, who got interested in what we were doing. And they talked about, they were the Happold people, and they talked about this idea that, you know, something like the Millennium Dome potentially suggests a very different way of building a project and developing a project. That the kind of Great Roof project there, if one were to produce the Great Roof first, then suddenly creates a very different economy of development under that roof. So that was something that we found quite interesting, and it really ran counter to a lot of the assumptions we were making in the project when we were presenting it. So here another view. I mean, I guess I could say in closing that the project was very interesting to us, and really we thought all of the projects that were done put forward in ways that were very different from the assumptions of the city and of more sort of conservative architects, I would say, about the possibility of doing, you know, large-scale structures, of kind of vast structures in a city like New York, and that this context in particular provided that opportunity, that there was that dual nature of both the global and the local, and how those interact in an area like this. So I guess we take our hats off to all of our competitors, and you know, we're very interested in ourselves in pursuing projects with the city like that. Okay. Thank you.
Questions? So do we have a mic, maybe? Are there any questions?
No questions? Well, that's fine.
Thanks, Jesse. We should ask you a question before you. I think it would be great if you could clarify one point for me.
Yes.
And that is to do with when you were touching on the work of Le Recollet.
Yes.
I think one of the very interesting comments that you made was the way in which Le Recollet didn't really push the concept of the deformation of the objects in order to arrive at the moment of failure, but in fact
Yes.
to see the kind of conditions or formations that he went through in order to arrive at that moment of failure.
Yes.
And so I think in terms of that project and some of the other things, for example, like Gaudi, there is maybe the way to express something of the relationship between spatial organizations, in some sense, and the kind of affectual conditions that they produce.
Yes.
If you are developing this same argument, then I think you use the analogy with the aeronautics industry, for example. There is at times not a one-to-one correlation, but there are very specific methods of investigation in terms of the correspondence between certain techniques or certain structural formations, and then the affectual conditions of these, for example, whether the plane flies or doesn't fly and things like this.
Right.
This situation is obviously much harder to examine in architecture.
Right.
So somehow you're still operating by analogy in terms of, or at least it seems that one is operating with analogy, through analogy, in terms of the correspondence between structural investigations and their performative conditions. What I'm sort of missing a little bit is how you equate in these projects this relationship between the structural deformations and their performative conditions, because what tends to be prioritized is still the condition of structural formations, somehow semi-independently or autonomously of their performativity. And independent of that, there is automatically a kind of tendency to move towards the expressive quality of the structural rather than the relationality of the structural and the performative. So if you could maybe say something about that.
Well, yeah, it's a complicated terrain because it really means that one can't clearly separate the performative, the experiential, the structural out, right? And so I guess my answer to that would be that there would be, and what we were striving to do would be to make a kind of be mobile in what we were doing, that one couldn't look at any one characteristic. Say if one were working from within a certain lens, like the structural lens, would ultimately exhaust itself if one were simply producing variation or deformations in an aimless way. So the task and the kind of the work that we were trying to do really attempted to work in parallel and to find ways in which, say, a structural possibility, what a structure may be or a structural arrangement is capable of, then meshes, say, with some other agenda of surface organization and flow and program. So that there would be a kind of oscillation in the process of working, between some imperatives, say, of programmatic arrangement, which we would lay down roughly, some organization of flow and connectivity, and then the structural mesh that would be, accommodating it or producing the zone. But they finally, become inseparable from one another. I mean, that there would be at least a desire that they actually would come together, and there would be a kind of correspondence among those different material and organizational, categories.
But is there specific techniques that you're using in your work to actually evaluate in whatever terms these correspondences or these relationships? For example, I think one of the inherent difficulties, I was just saying this to Brett, one of the inherent difficulties seems to be with the method of rendering. On the one hand, I don't mean in your work, I mean the techniques of computer rendering, is that on the one hand you discuss a kind of deviation or distancing from conditions of anthropomorphism and so on and so forth. On the other hand, with these techniques of rendering, you're actually producing certain conditions of experience of building, which is more anthropomorphic than any of the architects that you're criticizing doing, 20 or 30 years ago.
Sure. No, I would say though, it has to do with the use value and when those renderings are produced. I mean, I would just want to caution that this presentation is for mainly, or was put together originally, although I added sketches and things that I wouldn't have shown, for public consumption. And the renderings...
That's us here.
Right, okay. I mean, but of a different kind of public. I would have to say this. There's a political dimension to the use of renderings. So I honestly would never use perspectives or renderings for design. And those things are produced after the fact because people expect to want to feel like they're in the space and so forth. But absolutely, I mean, I would say that we just don't design in perspective. It's sort of almost a useless, or those views are are used for a very specific purpose after the thing is designed. So yeah. Yeah. Actually, I didn't show the modeling, the physical modeling that went into it. There were wax models produced that we actually used for the development of the spline lines of the space frame 2. So there was a lot of process that wasn't fully put in there as well, but it's a sort of a different backroom stuff versus public presentation stuff.
Yeah, I want to say something about, pick up where Moisen was coming in. I think I can sense and I realize in the project that there is this, what you might call the coevolution between the kind of programmatic scape and labeling and understanding. And for me, I would say that the renderings are in the end part of that. That this kind of imagining a kind of life process and event systems and programs relative to a semi-autonomous setting of a structural concept, and I would think that what is indicative of that is also this kind of moment of symmetry versus kind of symmetry breaking, where I think that happens, where one can, to a large extent, symmetry might stand for the kind of purity, the autonomous structure kind of setting into the side, and wherever we start to recognize turbulences, deformations, asymmetries, left and right, there is a moment of specific setting where you start to label the turbulence as this particular,
right.
for instance, theater, etc. In brackets, because there's also an element of, I think, where the two shopping malls come in as symmetrical programs. That is partially the case, but I definitely I understand that your answer is very precise. I think recognizing that there's a kind of parallel investigation and reading of what the structure has evolved in terms of programmatics, and a kind of skinning of the program works hand in hand. And I think I sense it in the project. I think it's staggeringly kind of well developed in its geometry and through the kind of 3D modeling and physical modeling. And even there, to a certain extent, they're parallel strands, I suspect, because they're not absolutely matching.
Yeah,
but
they don't match.
For the size of what you're presenting, an incredibly kind of coherent organism. And for me, it would be curious the kind of team organization which makes that possible in the office to achieve these huge files. How do you partition off, and how do you in a fast process make these simultaneous strands of investigation cohere? I'm very impressed.
Okay. Thank you. Yes?
On what basis do you decide that something will be straight and something will be curved? Or to put it in a different way, on what basis do you decide that you will have megastructure which will be irregular and turbulent, and on the other hand, hotels which are slab blocks which are very regular together with box-like theaters, for example?
Well, I guess it's hard to say in the abstract what an absolute criterion for those decisions, but I guess I could say that in sort of following what Patrick was saying, what we set up in particular with this project was an idea that there would be, because I guess the overall site, for example, was essentially could be seen in that corridor as a kind of symmetrical cut. It conditioned a certain symmetry in the overall sort of proposition of the roof, and then and it would be the most reasonable way, and in a certain sense, probably the most economical way of dealing with that initial move. And then the kind of deviations and the kind of breaking of the symmetry would relate to more localized conditions, actually of symmetry too, in many of the programs, impinging on that overall dimension. So it wasn't obviously entirely about an economy in the sense of what is cheapest, but that there was a kind of, both in the sort of overall sort of configuration of certain major elements and then the introduction of minor elements programmatically and so forth, a way of coming up with a notion of, of this change. Now, in terms of curvilinearity versus regularity, I mean, I guess the idea there, too, would be to manage it in terms of what kind of a field would be produced around those programs. So the curvilinearity and the kind of turbulences that were produced were more or less in the zone that dealt with more intimate uses. We were looking at Central Park as a major sort of model in that way. It was a landscape model that we were looking at. And we were taking it very seriously in terms of a kind of a loose yet specific relationship between a morphology and certain kinds of events or certain kinds of programmatic possibilities. So, yeah, I mean, I wouldn't be able to kind of answer absolutely your question as a kind of dogmatic question, but it was more about, a set of organizational models that we were looking at, from an allied sort of field, and one that would be appropriate to that scale and to those events, and seeing how they could correlate to what we were doing.
I might maybe add one comment to that last question.
Yeah.
What's interesting to sort of compare maybe the two projects that you focused on, and maybe in the larger comparative forum that they are competition entries that either another 4 projects or another, I don't know exactly how many graphs, but that the 2 projects that you present do address the question of the normative and to what extent there is a window or where there is opportunity for that, the moments of the extraordinary, and that there is a sort of thesis, perhaps, that one can relate the 2 projects, that there is an exercise to test where the kind of programmatic aspects of the project are to be either delineated as normative and that enable
Right.
the extraordinary, and whether that dialectic is something
Yes.
is something that can be challenged or not. I think that is being challenged, but
Right.
it's clearly something that is at
Yeah.
work.
Well, I mean, the curve, in a way, is related to that whole argument of the Klineman, too, where that you actually, it's regular until some other forces come into play, and then you get the deviation or the swerve, and it usually is an attempt to somehow integrate difference, and that's how it resolves itself in this kind of, in the curvatures or in the deviations or the turbulences.